Fantastic. Please help what it's saying. Conda Sai Pi. No, Unica. So you are at base now. You have to change to TensorFlow. Thank you, Paul. Did the change? No, you didn't. Benson, is it fixed? Okay, better one day you come to lab. Everything will be sorted out. Okay. Online team, can you hear me or not? All right. Okay. So yes, sir, it fixed. Thank you. Do you remember, guys? I given you one task, which is feedback analysis. What is the name of the task? Feedback analysis. In the feedback analysis, I want you to add more data. Did you add the more data? You know what is the maximum accuracies? Some of my students, they got 90 percentages, but 8:30 a.m., none of them got 90 for this one. So Ayushi, what I want you to do at Ayushi, can you please duplicate 2 times? You're done? Your name, right? Duplicate 2 times and are you build or not? After duplicates. So, okay, fantastic. Oh, that's great. I need this GNB logistic. Good. Okay, so this is what we want. Did you try this, guys? So now in interview, if someone asks you, what are the issues you face? These are the challenges you face, and how do you overcome it? This is the way you overcome it. You can say like that. Understand you? Okay, so let's start today's sessions, guys. And I think let's open this. Let me open today's class notes. We start at 9th March. When we start this batch, guys? 10th March, April, May, June. Okay, this is 3.5 months. All right. What is today's date, guys? I think 22nd. Okay, so we are working on CNN part. Okay, we're working on CNN, convolutions, neural network, convolutions, neural network. Understanding? Okay. Now, the first thing we discuss, like first we have images, then we split into convolutions layer. Okay, and then we apply max pooling. And once we apply, then we use types 1D vectors, 1D vector, isn't it? And in 1D vector, this is single dimensions vector, isn't it? This is single dimensions vector. Then what we do, guys? Fully connected layer. This is what we done, isn't it? But before that, let's discuss. Today we build one projects. I mean, the projects is called mood classifications using TensorFlow, and Keras as well. All right, but before we get start, I wanted to talk about what is difference between ANN versus CNN. Okay, so let's understand in ANN what are the values are adjusted, guys. Weights are adjusted, isn't it, team? Weights are, but in CNN the filter values are adjusted. Are you guys understand? In CNN, what happened? The filter value are adjusted. So let's continue. So the first thing, let's assume we have input neurons. This is input neurons, and this would be the hidden neurons, and this would be the output neurons, right? Let's pass the signal using forward propagations. Let's pass the signal using forward propagations. So at back propagations, what happened? The W1, I mean the W1, W2, W3, W4, and W1 new, W2 new, W3 new. We do this, isn't it? The weights are adjusted over here. But in filter, what happened, guys? So let's assume this would be the input matrix, isn't it? This would be the input matrix. This would be the filter. This would be filter, and this would be output matrix. Are you guys understand or not? So we do striding or not, guys? But while you do back propagations, what happened? The filter values are adjusted. Understand, team? So the back propagation. So here also, the weights will be adjusted at back propagations, but rather than hidden layer, we don't have hidden layer over here. So the filter values will be adjusted in ANN versus CNN. Rest of thing is same. Rest of things is same. Team, are you getting me? Online team. So let's continue this one. Let's continue this one, guys. Minimize and before that, 1 second. Okay, so let's do this. Okay, so guys, today we understand and what are the activation functions, softmax. So there are classification is two type. Remember, the first thing is binary class classifications, and second one is multi-class classifications. I guys understand or not? So the first one is binary class classifications, and the second one is multi-class classifications. So what is binary class classifications? When the outputs are only binary, means 0 and 1. So here multi-class, when the outputs are many classes, isn't it? So like whether it is a horse, dog, and elephant, and some other images, all those things comes into multi-class classifications. Am I clear or not, guys? So let's understand the name of the projects which we building. I mean, mood classifications using CNN. So how you do this? So the first thing we understood in detail. So you can also build with your images, not any other actors' images, guys, because you cannot understand other people' mood. You understand your mood. Are you guys getting my point? So you know when you're tired, when you smile, when you're happy, when you're sad. You know this, not other. No, I mean, other persons can know about this. So to build these projects, I want you to follow the few steps. The first thing is create 3 folders in your desktop. What you need to create, guys? Create 3 folders in your desktop. So the mandatory. So the first step is create 3 folders. The first folder is training. The second folder is testing. And the third folder is validations. Understand, guys? Training, testing, validations. Where to create? In the but before that, what I want to do, before you create, first go to your Google Photos, okay, and try to extract almost like 100 pics, guys. How many pics, guys? 100 pics out of 100 pics, or maybe 80, minimum 50 to 100 you can try, so you get to know what is a runtime. Sometimes if your system hangs, then you can go with GPU, then we can go with GPU. Everybody know how to work with GPU, isn't it? So first you Google Photos, not phone. Google Photos 100 pics. Out of the 100 pics, take some of the happy pics and take some of the sad pics. Some of the sad pics. I can understand or not, everybody. So after this, you download some of the pictures, and then where you need to take some of happy pictures and some of take sad pictures, guys. Understand, team? Now, so for example, and the first step is, and I'll mention, and I can say please collect minimum 60 pics, guys. Okay. And out of the 60 pics, collect some of them. I mean, few collect happy pics and sad pics as well. All right, guys. So what you need to do, so the two things here, create 3 folders in desktop, first options. And what are the 3 folders? As training, testing, and validation. So just do like this. I mean to say, go to this here and 1 second, happy or sad. Now training, testing, validations. Are we done or not? Training, testing, and validations. So how many pictures you need to download? 100 photos, you images, not anybody's images. You download and you can update in the classroom as well. Once you're done, let's see, in training again, make 2 subfolders. In training, what you need to do, guys, make 2 subfolders. What are the folders? Happy and not happy. What are the 2 subfolders, guys? Happy and not happy. So means I download some of my pictures, okay, and 1 2 3 4 5 6. So as I just, okay, so how many pictures I downloaded? 6 images I load for me, and then not happy, almost like 5 pictures I have. See here, these are projects. I just don't want to see my, okay, all those things. Just don't take misunderstand all those things, guys. Okay, so this is training. We collected 2 folders. Few of them happy folders, few of them are not happy folders. All right, so randomly I pick some sample to show you guys. Clear or not? The next one, training. Next, go to testing. In the testing, you can randomly pick some photos, or you can also make it into 2 subfolders, happy and not happy, guys. Understand him or not? And then validations. I make file as empty. Happy, I make file as empty. Not happy also, I make the file as empty. So just what I do right now, so the first step is I collected around 60 photos. All right, I collected around 60 pics. Out of the 60 pics, these pics contains happy and sad, isn't it? And then second one, in the folder created training, in the training, TRAN, in the training happy faces, one folder happy folder, and other folder is not happy. Clear or not? I guys understand? The next one, the third one, testing, same. If you have time, you can create happy folder and not happy folder. And fourth, validation, also you can create happy and not happy folder. Remember one thing, if training pictures is always greater than testing pictures. I mean to say, in the training, if you have 100 pictures, for testing it should be 50. And testing should be greater than validations. In the validation, 50 should be maybe 20. Are you guys understand or not? I mean to say, training, the pictures which you load, it should be 100, but test it should be less, and validation it should be 20. Understand? I mean, training, you need to train a lot of pictures, guys. Team, did you understand? So up to this, we clear. So in this, what I done, I make a folder in the desktop and I make 3 subfolders, training, testing, validations. I create 2 folders, and testing, I didn't create any folders, randomly feed this pictures, and validations also happy and not happy. I didn't load any of the pics here, guys. Clear up to this? So the data is, we collected the data. We collected the image data. We collected the image data, isn't it, team? So it means your images. All right. And don't collect Katrina Kaif images, because you don't know when she's happy or sad. Are you guys getting my point? So you do your photos. Don't say, sir, I'm ugly, and so nobody will check it. You will test yourself. Understand, team? Okay. So the next step is Next step is, okay, so paste all the photos in testing part. This should be different. Anyways, the first thing. So did you see, if you see this code we writing from, this is code optimizations or not? Did you see from length line, then short line, then short line? Always you try to write. So that's why the memory also, there's a high chance of memory saving if you write like this. Understand, team? So we already done this image data generator. What exactly we do this, guys? It will generate the augmented images. Yesterday we done this. TensorFlow.keras pre-processing import image. Okay. Keras.preprocessing. This is very important package, and a little bit review about this we already done. See, I will have one projects which I'm introduced to PyTesseract. I never introduced to any of the batch, but I will introduce this one. And nowadays, PyTesseract OCR is a little bit more limelight. So let me talk about this. So this one, so here, if we go back to this one, TensorFlow module is a part of library that provides set of utilities for data pre-processing, data augmentations for deep learning. Are you guys understand or not? Yesterday we done this. So for this one, let me go back, and what we do is image, matplotlib, TensorFlow, NumPy, CV2 OS. Are we done or not? Let's run everything, guys. Let's run everything's. Yesterday I had issue with the CV2. Let's try. You may understand up to this. Now the next one, image load underscore image. Yesterday are we done or not? What is meant by load underscore image? It load the image from the folder. It load the image from the folder. And at this moment, I have where I have three folders: training, testing, validations. Which folder I need to load the image? Training, happy, image number 3. So let's go ahead and we run this, guys. Once we run, let's show the image. Okay, so I'm just with my kid, and so this is show the image, guys. Are you guys understand or not? So this image, I have plenty of images. Out of that, I load one of the images here, right? And right click, open images, new tab. But before that, do you see, if you see the dimensions or not? Look at the dimensions, isn't it? This is length, this is width. Can we say this? Okay, now I will come back to this. One moment. So cv2.imread, what exactly this one, guys? cv2.imread means if you open this, what is meant by read function does? It brief load an image from a file, isn't it? This functions load an image from the specified file and return it if the image cannot be read. If you don't have an image, then it can't be read, isn't it, guys? So what exactly we done? .im read. And these all the functions we calling from inbuilt functionalities of CV2. Inbuilt functionalities of CV2. So team, are you understand? Very simple. What we done right now, we call the necessary packages, and then we load the image. And once we load the image, IM show. What is IM show? Show the image. Check this. IM show. Show the image, guys. Okay. Just go back and display data as an image, that is on a 2D regular, which is, guys, the input may either be actual RGB, actual red, green, blue colored images or not. So that's why we got the colored images here. Understand, team? Okay, CMap, gray, all those things we have. Now let me continue this one. We load the images and IM read. So how to read this image? I have one image, but how to read that? Let's check this. This image to array. Are you understand? So what exactly happened? These arrays, who created this, guys? This is created by your CV2 package or not? Front end is this image, guys. What is back end? The back end is all these channels is defined. Team, did you understand or not? So that's front end. And what is back end? That's called image to array, array to image. And then we check this I1 dot shape. So this image contains this image based on pixels. That's right. And also how the pixels are defined. As I said, pixels are ranging from what, guys? 0 to 255. Agree or not? Let's say I'll talk about, do you remember maximum time you buy the colors called low red or light red color, isn't it? When we talk about light red color, the pixels value goes to 0 to 50 because starting point is light. Did you understand? When you say dark red, what is meant by that? The pixel goes to 200 to 255. Do you understand or not? Light red, light green, low green, dark green. That means these pixels will speak a lot about all these things, guys. So I mean to say, did you see as this is colored images? So look at this 253, dark or not? 250, 245. So all the maximum values you haven't seen somewhere, but wherever you see 49. So guys, this not possible with manual understanding. If I ask you, I give you this image, and from this image, I want you to please print out this. This is highly impossible to do manually, isn't it, Tim? So yeah, so definitely all the 3D channels. So look at the shape. This image shape is, why are you coming late, buddy, every day? Okay. So the shape of the image is what exactly, guys? Let me check this. So tuple length 3. So here, this is height 4623. 44623. Can I say this or not, guys? And then what is the height of this? 3460. 3460. Can we say this? See, don't say 3000. We have some more values around here, isn't it? So this is, one moment, let me clear all those things. So 3D, shape of the image, height of the image, weight of the image, RGB. Now, when you load another image, what happened? The height weight will change or not? Definitely it will change. So that's why height and image weight will be changed. But training image data generator rescale 1 by 2 and 255. Validations rescale 1 by 255. What is mean by that? That means let's go to the folder and let's open, and here in the training, I load some of the images. But if you see, what is the properties of this image? 1.78 MB. This one, 2.12 MB. This one, that means each and every images properties are different or not? Did you understand? So that's the reason we need to be scale the data. So you need to be rescale the data. How to rescale the data? So means 1 by 2. To scale all the images, I need to divide with 255. In NLTK, do you remember when I explained text summarizations projects, how to compute the frequencies? 1 by max or not? With the maximum values, then only we get weighted frequency. The same way, I wanted to rescale this data, guys. We need to resize images using, you can pick now what exactly happened. Once you rescaled, you make a standard format saying each and every pixels or images has to be equal scale. So let's try to do this. Before you guys, are you clear up to this? Crystal clear? So if you do the same projects in Java, C++, it's highly impossible. It's possible, but take a lot of times. If they would have been done, they would have been done 10 years back. Isn't it, guys? They would have been done 15 years back because Java, C, C++ available in the world since decade. Am I correct or not? At that time also engineers are there, researchers are there, but still they're not done it because that's technology grows. Technology grows rapidly, isn't it? So let's talk about this one. Now the next step is train, image data rescales. Are we done or not? The next step today, I will talk about very important thing, flow from directory. What is mean by flow from directory? Flow from directory, everything's is the functionalities of CV2. Everything is functionalities of CV2. So before that, I will give you a little bit informations of open CV documentations. Let's go ahead and we do this. Okay. So this has also a GitHub repo for this one. Okay. And see, it is an ocean, guys. Okay. So how to extra modules, all those things. I hope you heard about alpha matting and image processing, legacy support. There's a multiple things. Okay, look at this stereo, shape, SFM, rapid. There's a multiple things. We have introductions to OpenCV and GUI features, core operations, image processing, feature detections, video analysis, camera calibrations and 3D reconstructions, machine learning, computations, object detections, OpenCV, Python, binding. So there are multiple things we have. And when you go back and check each and every time, it's a research once again. Are you guys getting my point? So OpenCV is a separate topic. OpenCV engineers, its job to learn the job, you must need to understand ML. To learn the ML, then you must need to understand the DL, isn't it, guys? So all those things are associated with it. All those things are connected with each other. So understand, just go to the modules. Once you go to the modules, there are plenty of modules. CUDA means when you install GPU machines, then you need to install with CUDA versions. All right, and video analysis, camera. I don't need to go back, but I directly get back some of the projects, and then you guys can understand more. Still, this is in research, guys. Are you getting my point? Still, this is in research phase. Now, if you're good at Java developer, if you're good at C, if you're good at C++, try to build the applications in OpenCV. Trust me, the recognize which you not got in C, C++, you get in OpenCV fractions of a time. Did you understand? I know, because in this batches, there are good coders also there. So I'm just small advice to you, the amount of time which is spent in C, C++, Java, if you spend the same time in OpenCV, you become a marvelous and you get back to the OpenCV engineers. Team, are you getting my point? So if you have still any confusions, please, it's open window. You can always reach out to me. Am I clear? All right. Now the next step is, we discuss this one. Okay, so the first thing is wait key. I haven't covered this, but I thought to cover this one. Okay, now this kernel restart and clear all outputs. Flow from directory. So flow from directory, this is directory target size 256, color mode, RGB, class mode, category, happy or sad. It is a category or not? Okay, batch size by default is 32 and docstring takes the path. What exactly mean by dot flow from directory? Takes the path to directory and generate batches of augmented data. Generate batches of argument data. So what exactly happens? So before I train, so I need to train the training part or not, guys? So look at this flow from directory. I use my path locations at training. In training, we have two subfolders or not? Happy and not happy. Yeah. So for every folder's target size is 200 into 200. We finalize what is the input train, guys? 200. What's the batch size? 32. What are the class mode? Binary. Because we have to binary classifications. Happy or not happy. Is this binary or not? So that's why the class mode is binary. If you have multi-class, I will tell you what is the category. The class mode is category. Okay, I will get back to that. Let's go back and we train the model. And we found 11 images belong to two classes. So go to the folder locations and up and goes up. Training, happy contains 6 images and not happy contains 5. So 6, 5, how much, guys? Overall 11 images, isn't it? 11 images belong to how many classes, guys? two classes. Am I clear up to this or not? Next one, we train from directory for this locations. Now the next step, validations. Validations. Now let's do this. Do I have any images from validations, guys? We need to test it, not, are you guys getting me? Now just go ahead and check this. Found zero images belong to two class. So today, as I said, you can create list of images at training folders, testing folders, and validations folders. Make sure training folders should greater than testing, and testing images should greater than validations. You can do this today. Now train dataset dot class indices. When you do this, happy means 0, not happy means 1, isn't it? So we need to convert to the happy to 0 and not happy to 1. So once we do this, just have a look at it. Happy to 0 and train underscore dataset dot classes. That means 0, 0, 0. So just now I said in training, we have two folders. Happy faces, 6 images. Sad, how many images, guys? Are you clear up to this? Isn't it? Next one. Next one. So guys, this code, do you think it is very hard? I not even if written anything here, we just assign the objects, assign the images sizes, and that's it. We're not doing anything at all. Isn't it, team? Now the next one. So that's why using help of ChatGPT, learning data science is very easy, guys. Next one. So yesterday I was working with PyTesseract with the less time, but I mean I was compare myself. I mean install the packages now and then. It's very easy. Everything's done in fractions of a second. So companies' productivity is more work, isn't it? Okay. Now next talk about this one. Now we are applying max pooling. So this is very important part. Whatever theories I covered to you, those things just comes here. The first thing, sequential layer. We need to establish the layer or not. tf.keras. Look at this. tf.keras, TensorFlow keras, backend, front end, isn't it? Models, sequential. What is sequentials, guys? It is a linear stack of layers, as we discussed. If you see this model add dense, dense means what? It is connected from one neuron to other neuron. All those things we discuss in ANN part. And then model sequential batch input size by default is 32, 30, right? So one neuron to other neuron. Here, tf.keras layers, okay, when you add the layers, convert 2D. What is meant by convolutions 2D, guys? Convolutions layer or not? What is the first step? We have one image and I need to train that image. The first step is what, guys? Convolutions layer. In the conv 2D, what exactly is? What is filters? 3 into 3 filters or not? And stride by default is, what are the stride I told you? What is the by default stride? 1 or not, guys? 1 step horizontal, 1 step vertical. Yeah, no problem. So here, see, batch size means it will consider how many one epoch. In when I train one model, 32 records make a batch and trained. That's what batch size. All right. Now the padding is valid. Valid means by default, it will take, pads, guys. Kernel initiates. This is the kernel initializer. There are Glorot uniform. Okay. I will talk about the kernels, regularizations, all those things. 2D convolutions array. So special convolutions, this layer creates convolutions kernel that is that is convolved with the layer input tensor. I mean to say, by default 2D convolutions array. To make a convolutions layer, we have to make conv 2D. 2D means don't think it is 2 dimensions. This is the conv 2D we used to pass the filter. So this is 32, guys. And then we have 3 into 3. What exactly 3 into 3? Filters. What is activation? In input filter, we need to apply activations, which is ReLU. ReLU, we never implement at output layers. Always we implement an input and hidden. The similar way in convolutions also, three filters we applied here. Now, tf.keras, what exactly we happen? Now, yesterday I was talk about one input matrix, isn't it? And one filter and one output. Understand or not, guys? It's not now that you can also create with multiple input with, I mean, metrics, multiple filters, and this would be the output layers. Did you understand or not? For one image, that doesn't mean that it will create one, it will create plenty like input metrics and filters. Did you understand, team? So I forgot to tell you those things yesterday because I know once we get to know all those things we covered up. So tf.keras conv 2D 32, this is one layer, this is another one, this is another one, and 3233 max pull 2D. Isn't it? What exactly apply, guys? Max pulling 2D. Max pulling means what, guys? We pull feature map. So what exactly happened, guys? I want you to derive once again. Let's have some image, okay? And in this image, first I train with this input matrix, and this would be filters. This would be output matrix. We apply max pull here. Clear? For the same image, this is one part. Another part, this would be another input matrix. This would be filter. This would be output matrix. Another max pull we applied. And this would be this all the features of this image. And based on this multiple features, we can classify whether this is a face, whether it's a dog, whether this is a cat, all those things. And can we create multiple input metrics or not like that, guys? Isn't it? Then we apply filters. Then we apply max pulling 1, max pulling 2, max pulling 3. Then what is next step? Then we create a vectors, guys. Then we create a vectors. Online team, are you getting my point? What I'm trying to say? So in this case, what happened? In this case, what happened? This is one part. We apply max pulling. Same continue to 32. I've been changed the pixels 32, 64. So we have 3 input metrics, 3 max pulling, flatten. I hope understand, guys. But before that, max pull 2D. Check this, guys. Pool size by default is 2,2. Pool size by default is, and this one filter is by default 3,3. And then flatten. What is flatten does? What is flatten, guys? Anyone? It will convert to exactly. So flattens the input does not affect the batch size. If inputs are shaped without channel dimensions, batch 1. So default or channel first, all those things. Flatten layer, I hope we already covered this, guys. And then we apply flatten after the flatten. So what exactly happened? Flatten also the input neurons created. Now think ANN, that is input layer. Then we apply dense connected layer. Here we apply ANN once again, and then activation sigmoid at output layer. Team understand? We apply CNN and then we apply ANN in code. Now let's go ahead and we run this, guys. Once we train, one moment. Okay, we train the model. Now model.compile. In ANN we compile the model or not? How to compile? Loss functions. How many loss we have? How many loss functions we have? 2 loss. One is regressions loss. One is classifications loss. In regressions, we have MA, we have MSC, we have log loss, isn't it? And in classifications, what we have? Binary cross entropy. Very good. And what else? And then category cross entropy. Category cross entropy. Are you guys understand, team? So this is MA, MSC, all those things. So as the data set is binary, so what you do, we use binary cross entropy. Understand or not? If it is a category, I will tell you, I have more practical for you, okay, for this batch, and I want you to build a lot of things by your own, where I'll give you all the things Now, after this class, you pick any projects in CNN. Now, before the class, you don't know, but now you learned 50-60% you know. Any practical you pick from CNN. Am I clear? Now, let's go to the another topic. 3 into, but 16 here is pixels. Yes, the image is 16 is pixels. So that's why if you say this, Sashi, filtered kernel sizes. Okay. What is meant by 16 pixels? We converted. Yes. And then 32, then 64. You defined, it's not an issue. Okay. Next step. Once we go back, binary loss functions, optimizer. How many optimizers we have? How many optimizers? We have 6 to 7 or not? In ANN, what optimizers we used? In ANN, what we optimizers we used, team? Adam optimizers. Very good. So let me write down. Whenever you use image data, the optimizer always be RMS prop. What exactly, guys? RMS prop. Always learning rate to minimum or maximum. Learning rate in gradient descent always be minimum. Minimum means it's 0.0.1. So let's apply binary cross entropy tf.keras.optimizes RMS prop LR. Learning rate is not, guys. Dense. You don't know dense? I want you to see the ANN class. Dense means what, guys? This is connected between two neurons, input neurons, output neurons. Someone has to be passed the signal or not? To pass the signal, the connection is required. So if you apply the dot dense, this functionality taken by dense. Understand? We already covered in ANN Vinay. Now, RMS prop. A little bit check this one. Optimizers RMS prop. So how many optimizers we have? Okay, instances tf.keras.optimizes, you know. If you don't know, I already covered this. What are the optimizers? Okay, you can check this one more time. LR and matrix accuracy. Let's go ahead and we run this. Now the next step. The next step is, guys, we already done the same things in ANN. We already done the same things in ANN. Now model.fit train data. Fit the model. What is model we built? So this is what we model assigned or not? And then we train the model. Okay. And then we fit the model to train data set. In train data sets, we have happy or sad, isn't it? Epoch equal to 10. But before epoch, I'll make 3 epoch validations data and let's try. Did you see it take more time, guys? Do you understand or not? 1 second. Loss function 68. Reduce the loss. Accuracy is increasing or not? Reduce the loss. So here, this is 68 in third epoch. Now, I want to make it to maybe 10 epoch. Let's try. 1/10. In it's very fast, but CNN it's become slow or not? So if you trained with 100 images, now my questions to you, it would be slow down or very fast? It will slow. It will. That's why CNN models you can build in GPU. But no worries, you can try this first and then you can do this. What is the accuracy we got, guys? The maximum accuracy we got 90%, 90.91. It's a good model, isn't it? So the images which you train, the accuracies which you got is 90%, guys, like which is got 90%. Now let's understand this. See, what is the artificial intelligence? That means I have few images. I know human intelligence knows whether you're happy or sad. Now my machine's telling you that you're happy, your face is happy or sad. Did you see? I mean, machines also started thinking like a human. That's called AI. And how the machines thinks like that? Because of the packages. What are the packages? OpenCV, TensorFlow, Keras, all those things. Now the next step is directory path. I have some testing. These are the folders we have or not? Do you worry about loss also? No need to check this. Accuracy only important. Loss no need to check. Accuracy only important. Okay. So testing, we have some images team. Once we have testing, so for INOS, so how many images we have in the testing? One, two, these images we have or not, guys? In testing, if you create two folders, then you can get two folders data. If you have two folders, then you create a two folders data. Directory path. Now here, what is the target size we trained here? 200, 200 or not? Testing also 200, 200 we need to check, because testing also we have some images where the outputs are different. Now let's understand at the testing target size 200 and what exactly directory path. We already checked this. And here I want to show the images. Up to this, what I done, print I. Print I means what? How? What are the images we have? Now show the images at testing. We found all these images. Okay, we found all these images. And now what I need to do, this image I want to make a label. This image I want to make a label. So how to make a label? Just one moment. Okay, to make a label, directory path. This is what testing path. So I'm in testing path up to this week. Just now what we done, guys? We try to find what are the images we have at testing file, testing locations, right? Now, class indices. Do you remember what is class indices? 0 means happy, 1 means not happy, isn't it? So this, up to this one, we can get all the images. Now the next one, x equal to image to array and np.expand dimensions, np.stack of x. And then we validate the model. If validation equal to 0, then I'm happy. If else, I'm not happy, guys. So I'm combining this one plus model predict. Model we built or not? We train this model. And now when you find out, so this image predict, I'm not happy. And this one I'm 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 happy. And all those things we've been done, guys. All those things we've been done. Team, are you understand or not? So today, whatever theories we've been covered, whatever theory we covered today, all right? So we covered now the practicals. Are we understand or not? Are we understand? So where to apply max pooling, soft max is pending. So we are done. See, many projects we have in CNN. I will get back to you. Okay, we are done with binary class classifications. But what about multi-class? What about multi-class classifications? Is it important or not, guys? Multi-class classifications. So multi-class classifications, I will, every time you know about sigmoid activation functions only. Which one? Sigmoid. But you must need to know the softmax team. You must need to know softmax as well. Are you guys understanding? I will share this. Would you work this one? Would you work this one? So today and tomorrow, I will take it only 1 hour. From Monday onwards, I will take continue a little bit, 1 or 20 minutes, something like that. Okay, because the 10 a.m. the new demos starts. So I have to open all these files, guys. Clear, team? Okay, so I will share these projects to you. I want you to load all these things and please work on it. There's next week lot of, next week we'll talk about PySpark OpenCV, and we continue this. Tomorrow also we can continue like that, guys. So try to build all these things, you gain confident. Understand, him, and update all these things and get and LinkedIn. This is what people doing, isn't it? So the one you are doing just, but other institutes, they're telling you to make a decorations, how to make a decorations. But here I tell you the concepts. I'm not telling the decorations. You have to do the decorations. Do you understand what's meant by decorations? Make a PDF, make a problem statement, make a use case. Day 1, this is what learned. Day 2, this is what learned. Day 3, this is what learned. Make things, and then they can push it in the LinkedIn. In the world, they said, right? So whatever the way you show up as much, exactly, those decorations don't give confidence. True. That's for, okay, anyway. Guys, are you getting my point? I'm sure you gain every day a lot of confidence. Machine learning you understood, NLP understood, now deep learning, PySpark you installed. A lot of learnings, guys, within 4 months. Trust me, you never get anywhere. You go and join and then come back and tell me. Everybody has my number. You can check this. Am I clear? Please work and update and push to the LinkedIn. Let world knows about you. Isn't it? Okay. Thank you, guys. I will close everything.